All right, folks, this is question number 3. Number 3 asks us, which of the following would result in a biased interpretation of a scientific investigation? Well, for us to answer this question, we need to know what scientific bias is, or what bias is. Bias is any systematic error that influences the result of a study, consequently leading to improper conclusions. It's important to know that bias is not random, right? It's a consistent tendency to deviate from the truth. So let's go through and see if we can apply that to options A through D. Once again, let's apply the test taking strategies. Let's see if we can eliminate any wrong answers. I'm going to start at the top. Formulating a hypothesis based off of data that was not collected with modern technology. Did a little paraphrasing here. We saw a very similar question to this and one of the other questions in this review. Just because something was not using modern technology does not mean it's invalid, right? A lot of experiments can be done with simple machines. You can test gravity with a pendulum or a ball rolling down a plane. So this is not a good answer to indicate bias. Option B, sending an abstract of sending an abstract of the data analysis to colleagues for further review before publication. Well, in this step of the scientific method, peer review is a thing, and this is exactly what it's stating, right? We say we send our work to other people to see if they can find flaws with it or find things that maybe we were blind to. So this is actually a good thing. This is the opposite of bias. This is peers checking peers. Option C, rejecting the flawed data collected during a research because of known procedural errors, right? Rejecting flawed data due to known procedural areas. That sounds like it could be a case for bias, right? We're rejecting data, we're not including something. That seems like it could be a decent answer. Let's see if we can compare it to D. D says failing to include experimental data that would cause other scientists to call into question the validity of the research. This D is a much better answer than C for a couple reasons. C, sometimes if you want to reject some flawed data, sometimes you, the experimenter, can make mistakes. You could be doing something and you could start keeping time too soon. You could have some bad data points that sometimes it's okay to exclude. However, it is never okay to exclude information to try to deceive people, which what this is saying. So in this case, the best answer is D, failing to include experimental evidence to try to deceive other people. So this is our best example of bias. That was number 3.